Hi everyone, this is your host TCW. In this video I'd give you an introduction to the very basics of loops in the Blender add-on Animation Nodes. I want to show you an easy example to demonstrate the principles that make understanding animation node loops a lot easier. I wish I knew this when I started with animation nodes. Keeping this in mind will help you with the transition, especially from loops you know from coding, to loops in animation nodes where you use nodes. Let's start with our example creating a loop using the default iterator. Here I prepared a Blender project with a 3D viewport on the left and an animation nodes editor on the right. To start, I have to create a node tree first. Just click on the little plus symbol up here. Now I add the loop node, which represents the loop definition, and let's add the invoke loop node, which represents the loop execution. It also provides an interface to manage the data in and output, as we'll see later on. It's very important to keep this in mind and to distinguish the loop definition from the loop execution. So let me emphasize this by putting the node blocks into different frames and giving them some self-explanatory names like data interface and loop definition. So let me add a frame to the loop node, open the right side panel and type in the label. Now I add a frame to the invoke node and type in the second label here in the side panel also. This doesn't have any functional influence, but it helps to visually distinguish the two parts of the node tree. Let me give you a little side note here. A loop in animation nodes actually is a subprogram. We can prove this by taking a look under the hood. We can look at the generated code. Just select the loop node, open the right side panel, switch to the Node Tree tab and expand the Developer section. Below the execution code part, click Right and press the Select Area icon to put the code display where you want it. As you can see at line 14, there's a subprogram definition that contains a for-in loop, which currently does nothing. It only contains the command pass. But as you see, the code for the loop is ready to go and standing by to do its job. But now let's continue with our example. To keep things easy, let me create a vector list and show the data with a 3D viewer in the viewport. So I add a combine vector node and a 3D viewer and connect it to the combine vector node output. Let me now crank up the viewer size and select a nice color so we can see the result easily. We can see the 3D viewer is showing the vector location, and if I change the coordinates, the position of the vector changes accordingly. In this example, I restrict to 2 dimensions by looking at the x and the y axis only. By pressing 7 on the numpad, we can switch the 3D viewport to orthographic mode, looking down on the x and the y axis. If I now plug in the index to the x coordinate, we see only one vector, but I expect a number of vectors corresponding to the number of iterations. Well, this shows another pitfall to keep in mind. The regular viewers only show the last value of the loop. If you're not aware of this, you might get confused by the results the viewer is showing. Using the loop viewer would list all the values of each iteration, but because I want to show vector data in the viewport, let me choose another method. I simply add a vector list generator output and you see the socket being added to the invoke node. Now I connect the vector combine node output to the generator output node. If I now plug in the 3D viewer to the output socket of the invoke node, it displays the complete list of vectors. To make things a little more interesting, let me add a number map node now. feed it with the index and connect the result to the y coordinate of the vector compose node. We can export the other input to the interface by adding a parameter. If I plug in the second input to the new parameter socket, it will be added with the appropriate type. Let's give it a name like slope, and if I change this value, you'll notice that we now get a kind of simple function graph plotter and that it changes the slope of the graph. I can also add another number math node and select the add function. Let me now expose the second input to the node and call it offset. If I change the parameter, we can see the curve is shifted along the y-axis. Now I've exposed all parameters of a linear function to the data interface. This loop could now be used to generate a set of curves within a nested loop. I put some links to more detailed videos on animation nodes in the description below. I hope you enjoyed this video. Thanks for watching and stay tuned to another video on this channel.